It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. Hey, welcome to the live stream, everybody. I'm Chris, your host. I don't know why. I think it's like I don't know what it is, but I feel the need to introduce myself. I got to be honest, most of the people that are watching this probably know who I am, right? I mean, I'm assuming you didn't tune into my channel just randomly. I guess maybe on like Instagram, people, it just might be popping up in their feed or something. But anyways, welcome. Welcome to the stream. I'm Chris. So got a couple things as usual I want to talk about. Got not like a crazy list or anything, but I definitely want to go over a few of the more common questions, which some of them are kind of silly, but it's all good. It is what it is. But as usual, if y'all have questions that you want me to answer or things you want me to talk about, do me a favor and put them in the comments, whichever platform you're on, and put them in all capital letters if you can, because it helps me to be able to see it. But I try to pay attention to everything. So welcome to everybody. So we're streaming on multiple Facebook places, LinkedIn, Twitter or X, YouTube, and Instagram. So I guess I should probably do the TikTok thing, but I don't know. TikTok is weird. I have it. I post on there, but I've just never had a big following on TikTok, I guess. So I don't know. Let's see. Neil says, you're currently in a 10-week HVAC program, hoping to find work afterwards as a helper. Well, that's great, man. The pretty good odds you're going to be able to find work as a helper. Just depends on the area you're in. I will say a 10-week program is only going to give you some basic fundamentals. And, it's good. It's better than nothing, right? It's going to be hard to find a school that's going to truly give you everything you want. So, right on. I'm assuming it's Danny. Danny says, love the videos, helps you out a lot. That's really cool. I'm so glad that the videos do help people. I started these for my employees, as a training aid kind of a thing. And then, eventually made them public, and just kind of blew my mind what happened and where the channel went and stuff, but it's a pretty cool experience. Speaking of that, this upcoming weekend is the start of my AHR trip. So I'm going out to Vegas on Saturday, my wife and I, and Sunday we're doing kind of a, I don't know if you want to call it a meetup. It's kind of an awkward one. We're going hiking at Red Rock Canyon, and we're just kind of making it public. If anybody wants to come on Sunday morning, we're going to make a post with like the times and exactly where we're going to be going. But it's going to be at Red Rock Canyon. It's not very rideshare friendly, so keep that in mind. I don't think it's rideshare friendly at all, to be honest with you. So if you are not going to have a car, I don't know how you're going to get there. You need to research that. Obviously, I'm going to be in a car taking some friends. Actually, I need to reach out to those friends because I need to make sure that they want to ride with me. But anyways, that's the whole thing. So then we'll be Sunday night going to the HVAC Tactical Awards. And then Monday, Tuesday, we will be at the AHR trade show. We'll be there on Wednesday too, but just for part of the day. So Monday and Tuesday, it's pretty safe to say you can find me at the Parker Sporlin booth for most of the day. And then on Monday, I'll be at the Heatcraft Refrigeration booth from 2 to 3:30. And then Tuesday, most of the day at Parker Sporlin, except for 2 to 3 at Refrigeration Technologies. And then back at Sporlin for, so Monday and Tuesday, it's pretty safe to say you'll find me at Sporlin. I will post something on social media saying the booth numbers and all that stuff. If you guys want to come by and say hi, I definitely love to come by, have a conversation, take a picture, whatever you want to do. It's all great. My wife will be there, so she'll be helping us to kind of make sure that everybody gets my attention. And so something that happens with me at the trade shows is when you come up and you start talking to me, I tend to just like go off on tangents and talk and stuff. And so sometimes having my wife there really helps because she wrangles me and reminds me, hey, there's, this person wants to say hi to you or something like that. And so she helps to move things along and make sure that I don't just sit there and talk for 2 hours, because I genuinely love to give everybody all the attention that they want. If someone wants to come up and say hi to me, I'm going to try to give them as much time as they can. So definitely stop by and say hi if you guys are going to be in Vegas. Should be a great time. Vegas is always fun for AHR. It's one of my favorite ones. So what are the tools that I highly recommend to an up-and-coming service tech? That is a great question. So here's the thing. First off, as a new technician, especially as a person maybe that's in trade school or getting ready to get hired, don't buy a bunch of tools. Chill out. Find a company that's willing to hire you and then ask them what tools you need. Okay. I've had, and I know people get excited, but like years ago, I had an apprentice that came to work for me and he was so proud that he bought this tool set, which was great, but it's tools that you'll never use, like you don't need a claw hammer for taking nails out like that. You're not going to use that most of the time. Now, maybe as an installer, you might use something like that. But the whole point that I'm making is don't buy a bunch of tools. Okay. Depending on where you go as a technician, what area of the country you're in, everything's kind of a little bit different from company to company. My company, and in my area, it's pretty common, we provide the big stuff. So we provide vacuum pumps, torches, recovery machines, big ticket items. The company provides hand tools, cordless drills, digital gauge sets. That's the stuff that the technicians typically provide with us. Now it changes from everybody. And then we have a tool account where you can, you get so much money a year to spend on tools that are, work related and that kind of stuff. So just be cautious about buying a bunch of tools. Because you need to find out what your company provides instead of you blowing your wad on a bunch of stuff and then having to return it or something like that. So be cautious and find the company and get an idea what kind of tools you'll need before you start buying. Now, everybody has their favorite brand of tools. I like what works. I've worked with all, I've had several different tools over the years, and it just depends. It really just depends. So let me look in here, see what I'm missing here real quick, because there's a lot of stuff going on. And hello to everybody that's just coming in right now. I'm trying to answer questions between a bunch of the stuff. Ralph asks if I can explain a headmaster and its function. Yeah, I clearly can. And I can tell you in the easiest format, a headmaster is actually a brand name. Okay. Alco, I believe, owns the name Headmaster. but the generic term for it is a head pressure control valve, okay? So there's several different types. The easiest one to understand and break it down is an LAC valve. An LAC valve, let me just grab this. This will make this super simple. Got a bunch of different head pressure control valves here. I have an OROA valve right here. This is a Parker Sporlan OROA valve, okay? Head pressure control. This is a cutaway of an LAC valve that I did a couple years back. This is a non-cut LAC valve. This is another LAC valve that's for different capacity systems, okay? And then you have the dedicated holdback valves. So there's several different types, but the easiest way to understand this is an LAC valve, okay? So basically, when we look at this, right on the side of the valve itself. Now, this is an LAC4, flip that over for you, LAC4 210 valve, okay? Sorry, I have to remember that there's a stream for Instagram and one for the other one. But this essentially is a head pressure control valve. The function of this valve is to maintain proper liquid temperature going to the expansion valve. That's the simplest form of this valve. Because our expansion valve, typically thermostatic expansion valves, they have a very small operating window. And what I mean by that is the valve can't have too low of liquid temperature going to the valve, right? Or it doesn't do really well with too high either, but that's a whole nother conversation, okay? So we want to maintain a minimum liquid temperature going to that valve to help the valve to operate properly. A thermostatic expansion valve is basically a dumb expansion valve, as opposed to an electronic expansion valve that can also be dumb in its own ways, but electronic is much more precise and it has much better superheat control. But its flaws are that it uses sensors that go bad, okay? But anyways, an LAC valve simply throttles down the refrigerant coming out of the liquid drain of the condenser. So you have a discharge line going into the condenser, then coming out of the condenser, you have a liquid drain that usually goes to your liquid line receiver, okay? So this intercepts that, throttles down the flow coming out of the condenser, okay? And then lets discharge gas directly from the inlet, or basically coming out of the compressor or just before it goes into the condenser, and pushes it through. But the very important thing that you need to understand is that an expansion valve, a thermostatic expansion valve, requires 100% solid column of liquid going to the expansion valve. So how does that work if we are dumping discharge vapor into the receiver? Well, because the receiver itself is going to have a certain amount of liquid refrigerant that's just sitting in there. We call it the flooded charge or the winter charge, okay? It sits in there all year long waiting for its moment to shine. And the moment that it tries to shine is when it gets cold enough outside that this head pressure control valve starts to throttle down the flow coming out of the condenser and then bypasses essentially and dumps vapor, high temperature, high pressure, superheated vapor coming directly off the discharge line, right? And it dumps it right into the receiver. Well, if you have that flooded charge, the proper amount of refrigerant sitting in that receiver just waiting, that vapor just pushes down on that liquid and you have a liquid seal in that receiver and it's just pushing down. So you have liquid refrigerant still going to your expansion valve, but this drives up the head pressure in the system, right? Liquid temperature, but drives up the head pressure. So this right here is simply there to make our thermostatic expansion valve operate properly, okay? Now, add this onto an ice machine, and it's going to have a few other features on it too, because we might have hot gas defrost or something like that, so it's going to help to maintain discharge gas temperature or different things like that. But in the simplest forms, this right here, head pressure control valve, an LAC valve, very simple, right? You see, all it has is a spring, a diaphragm, a pin, right? It has a gas charge up here, and all it's doing is just looking at the system pressure. Now, this particular one right here is an LAC 240. So this one starts to bypass below 240 PSI. and it starts to throttle down the flow coming out of the condenser, and then it bypasses the discharge gas right into the liquid line receiver, basically pushing back to the expansion valve, okay? So all it's there to do is just maintain head pressure. It's really not too complex. Now, you get into an OROA valve, they're very difficult to cut open. I've never been able to cut one completely, but I've seen them before, but I had to return them because Sporlan sent them to me to use in like videos and stuff, but like they had to spend a lot of money to have them cut away. So I don't have any cutaways for myself. This one right here, LAC valves, I actually did this myself. Just cut the valve in half and with a bandsaw, super easy. So hopefully that kind of makes sense. There's lots of great information. Parker Sporlan has lots of great information on the LAC valves. You can find more information at parkersporlan.com or sporlan.com, and then look up head pressure control valves, and you can find all sorts of information on them. So hopefully that helps you a little bit. Okay. Let's see what else we got going on in the chat here. Thanks, Jason. Anybody has any questions or things that I forget to cover, you want more information, shoot me an email, hvacrvideos@gmail.com. Okay. What's my favorite equipment or method to use for finding leaks? Just an electronic leak detector. I mean, I start with an electronic leak detector. Once you zero in on a general area where a refrigerant leak is, then I will pinpoint it, usually with soap bubbles. Big Blue from Refrigeration Technologies is the go-to one that I use. Then you pinpoint it that way. Personally, I don't like using dye. I've used it before. It just makes a mess and it makes a nightmare. Most of the time, if you have a good quality leak detector, you can find the leaks with that. So, all right, let's see. Reading through the chat, seeing what else I'm missing. Yeah, William Snyder says, ready to meet up with me again at HR. I'm looking forward to it, man. Definitely come up and say hi. Let's do it. All right. Cool. Sounds like Chris is in training mode. Yeah. I just go off on these tangents sometimes. So, can't the refrigerant leak out of the valve when it's cut in half? That's, nasty. I've never thought about that. That's a really good point. I probably shouldn't put this in the system when it's cut in half. That's a really good point, Nasty. That's funny. All right. Let's see what else we got going on in the chat. About 2 months ago, you asked about getting advice about getting into the trade. You took the advice and now you're here working refrigeration and you're loving it. That is awesome. That is really awesome. Congratulations. I'm glad that it worked out for you. And that's cutting threads. That's really cool, man. Would 2 liquid line filter dryers cause premature flashing and improper heat absorption because there's not enough liquid refrigerant to be able to boil inside the evaporator coil? Okay, so let's break that down. What do you mean by 2 liquid line filter dryers? Do we have 2 piped in series or piped in parallel? Okay, because if you have 2 piped in parallel, as long as you have the right amount of liquid refrigerant in the system, you should be fine. Now, if you have 2 liquid line dryers in series, one after another, you are going to create an excessive pressure drop, okay, that you can measure or check with the thermometer and you'll see the pressure drop, okay? Typically on a liquid line filter dryer, if it's sized correctly, you're going to see a 1 to 2 PSI pressure drop across that dryer. Anything higher than that, you start to see a problem. Well, if you have 2 of them piped in one after another, then yeah, you're going to run into a problem where you're going to create a pressure drop. That pressure drop is potentially going to cause flash gas and potentially affect the liquid performance in the refrigerant line. And that is going to affect the whole operation of the system. So yes. Now, when you say 2 dryers, you can have a suction dryer and a liquid dryer. Also, I can go off on a little bit of a tangent here too, because a lot of people, have anybody out there ever worked on a Manitowoc ice machine? Okay. Quiet Cube, Cool Vapor Defrost. They have a suction filter on them, right? And it's right before the accumulator. It sure looks like a suction filter dryer, but it's not. It's a suction filter, and it's there to protect the accumulator because they don't want the little pickup oil port at the bottom of the accumulator to get plugged up with gunk, so they put a suction filter on there. So keep in mind, tech tip of the day, don't assume that it's a filter dryer when it might just simply be a filter. Okay, a suction filter is going to have a lot less potential of plugging up because it's literally just a screen, as opposed to having desiccant in it that's actually going to try to dry the system up, right? And have much more of a pressure drop. So One was factory installed inside the condenser, and you don't think the installers realized, so they field in. Oh, it sounds like you're working on a Goodman unit, huh? That has the factory installed liquid line filter dryer in the condenser that you can't remove when you pump down the system. And then someone adds a liquid line filter dryer on the outside of the condensing unit too. And then now you have a double liquid line filter dryer. I mean, in theory, if it's not plugged up and you don't have a big pressure drop across it, you should be okay, but it could lead to some problems for sure. So, all right, cool. Let's see what else. Reading through the chat right now, seeing what else I'm missing. Okay, cool. That's that. I'm going to get a couple more things going on in here. So, let's see. Let's get to my little list right here. So, have I ever thought, this is like literally one of the most common questions, okay? Have I ever thought about using meta glasses in my videos instead of holding my phone when I'm walking around, right? Have I ever thought about using meta glasses like these ones right here that I actually have and wear quite often in my videos? This is the Generation 1 meta glasses. A lot of people don't know I had the Generation 1s for a long time, and now I have the Generation 2 meta glasses. So I personally have the Wayfarer models, and I have the transitional lenses on them. So they're clear inside, and then they tint and go to sunglasses when I go outside. So yeah, I use them. But the downside to having meta glasses is that they only record vertical. They don't record horizontal. So you can't use them for long form landscape version YouTube videos. You can only use them for short form content. They are getting longer and longer streaming times, but yeah, I have meta glasses and I have used them occasionally. There's some videos that I've used them in. I have all sorts of different stuff that I use occasionally for different stuff. So any advice when there's a wide open TXV when the subcooling and superheat are both low? Whew, man, that's a loaded question. I don't have any advice because I need to know a lot more about that system. So I would need a lot more information. You know, is the valve stuck? Is it sticky? Does it respond when you test the sensing bulb? Or is it simply, is the valve not sized correctly? Like there's so many different variables. So I would start with double checking before you go too crazy that everything is the right size. Okay. Do a load calculation, find out how big the expansion valve should be. Start with that stuff. Verify that the equipment is sized right. Verify the equipment's matched. Then start diving deep into figuring out what's causing it. Okay. How long have I been in the industry? So I got into, I'm second generation. My dad started in the trade long time ago, or sound like a Don McLean song over here. But he started a long time ago. And then I started working with him when I was a little kid, going to work with him, sitting on his bucket, holding his flashlight. And then I came to work with him officially full-time in 2002. And been doing it ever since. We partnered now together. We run the company together. My dad is basically about to retire. I keep saying that, but he's actually given me a deadline, a date, his official retirement date. So yeah, anyways, but that's where we're at. So I've been in the industry officially since 2002, but I grew up working in this industry. That's what I did every summer, working with my dad, making money. Some labor law violations, because when I was in junior high school, I remember coming to work with him all day long and I'd get paid $20 a day. $20 a day is what I would get. But for a 13-year-old kid, at the end of the summer, when you had a couple $100s, that was pretty good for working all summer. Man, a couple $100. You know how many CDs I could buy at the warehouse? And then if you were frugal and cheap like me, you'd go to the used CD selection and buy a CD from there that wasn't $20, because CDs actually used to be like 20 or 15 to $20, and they were like $9. So you could get a bunch of CDs with that couple $100. So how can you tell if the headmaster is faulty on a walk-in cooler? Scenario: sight glass was flashing, system didn't make temp when the weather was colder, but would start cooling when it got warmer. Wasn't sure if it was a charge issue or a head pressure control valve issue. Great question. So first off, understand that on a properly operating refrigeration system, let's just say it's a walk-in cooler that has a head pressure control valve. First off, head pressure control valves, they do have to be sized appropriately. If they are not sized appropriately, they can also cause problems, okay? You can't just necessarily throw an LAC valve on any system out there. You might have to change it up to an OROA valve, or you might have to change it up to something bigger than that, depending on the capacity of your system. The next thing to understand is that when you have a head pressure control valve and the system is operating properly, the coils aren't iced up, it needs to have a clear sight glass going to that expansion valve, preferably right at the expansion valve, but you need a solid column of liquid going to that expansion valve. What you're describing sounds to me like the system is not charged properly, okay? But I don't know for sure because there could be so many variables, but you need a solid column of liquid going to that expansion valve. Now, I say that with a caveat. Back in the day, there was a lot of R12 systems that when I came into the industry that were being retrofitted out, and we had drop-in replacements, 409A, MP39, MP66, all these different gases that were there to replace R12, okay? But here's the problem. If your system is not designed for those refrigerants, just because the supply house says that 409A is a great replacement for R12 doesn't mean that the system's designed for it. R12 was a very, very low pressure as far as normal refrigerant pressures compared to 409A. You know, it operated much better, right? But then when you got into the 400 series refrigerants, they started to run into problems. And in all reality, what needed to happen to change over to 409A was change the receiver size, put a bigger condenser on it, that kind of stuff, right? So the system has to be designed for the refrigerants it's working in. So that's why I say, as long as the system's operating properly, the coils are clear, it was designed right, you should have a solid column of liquid going to that expansion valve, okay? And if you have a flashing sight glass, you know, preferably as close to the expansion valve as possible, there's something wrong. It could be low charge. It could be restrictions. It could be all sorts of things. And that's what us as technicians have to figure out. So what I would highly suggest is Google Sporlan 90-30-1, okay? You will find a whole bunch of information on head pressure control valves and how to properly charge systems with head pressure control valves. If it has a tube and fin condenser, essentially in a nutshell, the 90-30-1 tech document is going to tell you to measure the diameter of the long runs on the condenser, find out the pipe size, calculate the internal volume. This sounds overwhelming, but it's really not that difficult. Calculate the internal volume of the condenser, figure out the density of the refrigerant based on the different refrigerants, figure out the temperatures at which your system's going to operate, and then Sporlan's 90-30-1 method is actually going to give you a number in pounds and ounces of how much extra refrigerant needs to go into that system for the flooded charge or the winter charge, okay? There's other ways to do it too. You can put the maximum amount of refrigerant in a system. Now, what is the maximum amount of refrigerant? Well, safe, you know, for, again, there's many variables here, okay? But you can never fill up a receiver more than 3/4 of the way when it's pumped down. You have to have that extra room for expansion. So when you pump a system down, I mean, you could put the maximum amount of refrigerant in that system, fill the receiver up to 3/4 of the way when it's pumped down. Then you know you can't put any more refrigerant in there safely. That's making an assumption that the system was designed right, and that's still enough refrigerant to operate the system. Again, you know, assumptions can get you in trouble for sure, okay? But hopefully that answers some of your questions there. Let's see what else. Have I worked on any ultra low NOx lately? I think I have a few ultra low NOx systems out there, but I don't do a lot of heating work. We really don't get a lot of issues here. Would I recommend replacing a TXV when a compressor is burnt out? Okay, so that's a great question. It depends on what you're working on, okay? If I'm working on a package unit, let's say a package unit that's a 10-ton package unit, and it has a grounded compressor, and the customer wants a quote to replace the compressor, I will typically add to my quote to change the expansion valve, the compressor, the accumulator if it has one, add a suction line filter dryer and a liquid line filter dryer, okay, to the system. And in a perfect world, put ball valves on each side of that liquid line filter dryer. And then if the customer goes for it, I will put extra time to come back about 2 weeks after the compressor's been changed out and do a pressure drop across the liquid line filter dryer and potentially change it again if we need to. Now, why would I change the TXV on a grounded compressor? Well, because it depends on the customer. Now, if it's a very understanding customer, I might not change the TXV. You know, I might just leave it alone. But if it's a customer that's kind of finicky and they don't want me to have to come back, then yeah, I might throw that into my quote. It just depends. But the big thing you need to understand is what can cause a compressor to go bad? What can cause it to ground? Well, does the customer do routine maintenance? Is the system been running with really high head pressure, causing the oil to degrade inside the compressor, which is causing the system not to work right? Does the system have pressure controls? I've come across air conditioning systems that don't have low pressure controls, which sounds dumb, but it happens, right? In those situations, we might have to make a judgment call. So every situation is going to be different, and I'm just going to evaluate it accordingly. But same thing, like for instance, if I have a heat pump unit that has a grounded compressor, more than likely it's going to be getting a reversing valve too, because how much time goes involved into recovering all the gas, changing out this component, when you can change a $300 reversing valve in an extra 30 minutes when you already have the compressor out and all the gas out. It's much easier than having to come back, recover the gas again, go through the whole process to find, after you started it up, the reversing valve's leaking by or something like that, okay? So another thing to understand too about expansion valves, if you have a Parker-Sporlin expansion valve, a good majority of them, you can pull the power head off that valve when you don't have any gas in the system, and you can inspect the internals of that valve. They're super easy. Let's see. This right here happens to be a flare valve that I cut apart, right, for a Parker-Sporlin valve. But I mean, if you look at the body right here, you have the body, you have the adjustment stem right here, you have the power head. If you can safely pull this apart, right, I'll pull this one apart. Look, there's a pin that comes out of here, right there, right? And then you have a seat and a spring. So we go ahead and unscrew this right here, and there we go. We have a seat and a spring. Now, sometimes the needle on this seat right here will get gummed up with gunk, and you can see that if you pull it apart. So maybe I don't change the whole valve. Maybe I just disassemble the valve so that way we can inspect it. That might happen too. So it all depends on the different situations and what can happen. But Parker-Sporlin expansion valves, majority of them are fully rebuildable. So you might not even have to change it. If you can get the same valve, sometimes I won't change the valve. I'll just rebuild it, pull all the guts out, put the new guts in there, and call it a day. Okay. If you suspect an expansion valve sticking, it might be some gunk and some oil sitting on this needle, not allowing it to flow properly, or the pin that sits at the top. I've seen these get gunked up with oil and grease. They can also be cleaned. Depending on what you're working on, you can pull those out with some brake cleaner, clean them up, put it back together, and it will work for years after that too. So everything changes. Be careful you don't lose the pin when changing. 100%. That is the truth. Yeah, very much so. So, all right, let's look at a couple more things. If your suction line is logged up with oil, it messes with your evaporator pressure. If your evaporator is oil logged, yep, forget about it. That's absolutely true. There's so many different variables, right? And what causes your evaporator to log with oil? Well, improperly adjusted expansion valves can cause the system. Refrigerant migration can cause the system to log with oil, because on a refrigerant migration situation, if your crankcase heater is not working on your compressor in the off cycle, that refrigerant might go somewhere else, right? It might migrate. All the liquid refrigerant might migrate to that compressor. And then when it starts up, boom, that refrigerant's now mixed with all the oil. When it starts up, it starts to foam, and it pushes all the oil out of the compressor, and then it gets stuck in the evaporator because it flows through the system. And then it gets stuck. And then, because it wasn't designed to bring that much oil back, or because you have a long line set or a pressure drop, now you have no way of getting that oil out of the evaporator, right? And it can be very difficult to clear a logged evaporator, because, for the longest time, I used to think like an evaporator just gets logged, like it literally just fills up with oil. That can happen. But then also that oil, it doesn't necessarily fill up the whole evaporator, but it can just coat the surfaces of the refrigerant lines for the whole evaporator and not allow it to absorb heat properly either. So it can be really confusing. Oil logs are some of the hardest things to diagnose and repair. They really are. So what's my thoughts on A2Ls? Look, when I came up in the industry, I told you that R12 was being phased out and we were dealing with 409, MP39, MP66, all these different drop-in replacements. And then, you know, we changed from 502 to 404. And, you know, there's always going to be refrigerant changing, right? If you're fighting changing refrigerants, just get out of the industry now, because guess what? If the hippies have their way, we're not going to have, I mean, I don't even know what refrigerant would be safe, right? Because we don't have enough water, so we can't use water. CO2 seems to be the popular thing right now, and propane seem to be the popular things, right? But propane is a byproduct of gasoline manufacturing, oil drilling, all that stuff, which is all horrible, right? And I get it. It can be bad, right? So if the hippies have their way, everything we do today will be banned tomorrow, right? But bottom line, the refrigerants you're using today, that's the crazy thing. So we're doing this A2L transition right now, right? Those refrigerants already have a end date. They're already being phased out. We're barely transitioning into them, and they already know that they're going to be gone in the next 10 years. They're going to be a new refrigerant. They don't know what refrigerant the new one is yet, but they know that the A2L refrigerants are out the door already too. So just hold on. Now, you know, is there some frustrating things about the A2L transition? Yes. We can go off on all kinds of tangents about, you know, of the, you know, the government, and just, yeah, we don't want to get too crazy into that. But like, yeah, the transition is kind of silly. Okay. I will give you that. But something that I do have to say is that in the refrigeration side, in the type of work that I do, I work with R290, which is pure unodorized propane. Like, seems like all the time we're working on a system that has R290, purely flammable. And A2L is mildly flammable, right? It doesn't sustain a flame. You can ignite it, but then when you move the flame away, it stops. Like, it doesn't. So yes, there could be bad things that happen. And yes, we still need to be careful as technicians, but don't stress. It's, you know, it's just the silliness. There's some things that we genuinely have no control over. And, you know, yes, I know that we can lobby for things and stuff, but like, there's some things that just don't freak me out. And the A2L transition doesn't really freak me out. What bothers me about the A2L transitions is the difficulty as a business owner and the crap I got to deal with. That's what bothers me, right? So did you know with the A2L refrigerants, right? Because nationwide, technically, it is against the law to use 404A refrigerant or even 448A refrigerant on a complete new system install for a walk-in, okay? And when I say complete new system install, there's some weird variables in there. Heatcraft's done a really good job of making sense of everything, and they've told me some of it, but some of it just goes in one ear and out the other. But in theory, if you change your entire system over, so you're still technically, I think, allowed to change an evaporator, and still use the old refrigerant out of California, not in California. California is a whole nother dynamic, but we all are supposed to be using A2L refrigerants, you know, everywhere and in the walk-in boxes and everything. So it's a little silly, some of the stuff. Like, for instance, the suction line needs a check valve, and you need a liquid line solenoid valve on the liquid line outside of the box. So that way, if the leak detector senses a leak, the liquid line solenoid valve that you installed for refrigerant mitigation shuts and pumps all the refrigerant out of the box, and then the suction check valve doesn't allow it to come back in. So that way there's very minimal refrigerant in the box when it detects a leak, because they're trying to prevent any combustible gases from building up inside the walk-in box. That doesn't sound too difficult, but when you have existing walk-in boxes that you can't necessarily get to because the lines are ran in the wall or they're in really weird places, that's going to be difficult to install liquid line solenoid valves. Or that liquid line solenoid valve, it technically has to be outside of the walk-in box, but not on the roof. It has to be as close as possible to the box. Well, some restaurants, that's a nightmare to do. So that's what bothers me as a business owner, trying to figure out the logistics of all of that. I'm not afraid of the refrigerants. I think that the safety crap that they're doing with these A2L refrigerants, in my personal opinion, and I'm sure I'm going to get crap for this, I think it's way overkill. There is none of this safety stuff for A3 refrigerants as of yet. But granted, to be fair, A3 refrigerants or propane, hydrocarbons, isobutane, propane, technically the charge limitations are a lot lower than A2L. So I guess in theory, if they were going to allow propane and R600 to be used in larger scales. They probably would have all these weird solenoid valves and all this crap that you have to install in the systems, but it's just kind of silly to me. Like, it seems like a little bit overkill. Hey, I don't understand why we just don't go to monoblock systems, right? Where you have a secondary cooling fluid being pumped into the house or the building, and you just have the flammable refrigerant outside, and then that just solves all of our problems. But anyways, okay, let's get to a couple more things. Let's see. I have a customer that needs a captive air VFD motor swapped in LA County. Is the best way to get a proposal to make a request through JVS, the 800 number? You diagnose the issue through captive air service. It depends. You can reach out to me, shoot me an email, hvacrvideos@gmail.com. It really depends on where in LA County this is, because I only service a very small portion of LA County. My service area is the Inland Empire, essentially. That's not really LA County, but shoot me an email. We can talk some more about that. Okay. Reading through the chat. What else do we got going on in here? You basically use, okay, cool. Let's get to a couple more things on here. In California, is all you can go technically if you have a trailer. Yes, in California, if you are towing a trailer by law, you cannot go over 55 miles an hour maximum unless the speed limit is posted less than that. Diesel trucks and anybody towing a trailer in the state of California, the maximum speed is 55 miles an hour or less. That is very common. And a lot of diesel truck drivers get really confused, and a lot of Californians get very confused, especially me when I go out of state for whatever. I go to North Carolina or something, and you get passed by a diesel truck in the fast lane towing a trailer doing 75 miles an hour. And I'm like, what just happened? Like, why? And they're just one after another because anyways, it's a whole thing. But yeah, that is the law in California. So all right, let's see what else we got going on. A couple more things. Have I retrofitted the new A2Ls to work with 410A? If so, what's the major retrofit? No, I have not done that yet. So, okay, so I already answered that question. Okay, this is another one. So I made a short the other day just kind of announcing that I built a walk-in box, right? I showed it in my live stream last week. I put a short on social media right outside my window right here. I have a giant concrete pad that I poured, and I have a big walk-in box that's a freezer and a cooler section. The most common question with that is, why the heck am I building that? Why not? Like, literally, does it surprise you? Like, again, I'm asking, is it, I don't know. It just dumbfounds me. But why not build a walk-in box? But genuinely, I'm doing it so that way I can make more content on it. Selfishly, I just want my own walk-in to be able to experiment on and play with. My technicians that work with me, they're going to be able to work on it a little bit and play with different things here and there. But when I do certain experiments, I thought it would be really cool to be able to film things that I don't necessarily get to do on my customers' equipment, because all the videos that I film are on borrowed equipment on borrowed time, essentially, right? So this is my time. This is my equipment. So I can purposely do things for whatever reason. I know why now, but for the longest time, I've been hoarding used parts. Don't know why. I'm like, I'll do something with that one day. Well, guess what? I know why I've been hoarding those used parts, because a lot of them are for walk-in equipment. Condenser fan motors that were going bad, circuit boards that are bad. I literally just replaced a circuit board on a Heatcraft Intelligent walk-in this weekend. I saved it. Why not? We could use it. Maybe if I end up going with intelligent equipment, which is a very good possibility, at some point, I could put that bad circuit board on there and show people some things that I may or may not be able to necessarily show on the customer's equipment that I can still film. So I still plan on filming on my customer's equipment, but the whole point in building the walk-in box is simply because I can, and I want to be able to do it, and I have an opportunity, right? So that's why I'm building a walk-in box. All right, and why I built it. So stay tuned. There should hopefully be some cool stuff. Yep. It's for training and just for me playing with things. So have I ever thought, okay, I already answered that one. Okay, so this is a great question. This actually is a really good one. And think about this one for a minute. This person says, why is it that older equipment seems to last longer than the new equipment? And, I think a lot of people instantly think that it's a conspiracy from the manufacturers, right? Planned obsolescence. I'm not going to say that that doesn't exist. That's the assumption that a manufacturer makes something with a planned shelf life, right? They know that this is only going to last and they plan for it to only last. Maybe they tweak some things to make it only last this long. And I'm sure that that does happen, but I think that's more of a conspiracy theory for majority of the cases. And you have to understand something. Government efficiency standards are what drives poor equipment shelf life, in my opinion, my personal opinion. Okay. And I agree that efficiency standards do need to go up. I'm just saying that the efficiency standards and the drive to make everything that much more efficient is what's causing everything to not work as well. Okay. And not last as long, because you need a higher SEER rating. You need a more efficient air conditioner, right? You want it to work better and give the customer more, or, you know, a lower cost of operating, whatever you want to say, right? It costs less to operate. Okay, well, one thing that they do to gain efficiency is they thin out the copper, the refrigerant copper that you use. And I'll challenge everybody out there. The next time you change out an evaporator, cut the evaporator with a Sawzall and look at the thickness of the copper pipe, okay? Then the next time you get an opportunity on a really old system, cut the evaporator that you change out and look at the thickness of the pipe. Totally noticeable difference between something from the 1980s, the copper thickness, and something from 2026. The copper thickness is so thin, and that's because they want it to be more efficient. They're trying to meet efficiency standards, and there's only so many ways you can do that. Better heat transfer, thinner copper. Okay, that's one of the main reasons. Then you add in all the fancy two-speed blower motors and VFDs and all this stuff. But what they don't do is they don't tell the customer that in order to have all this totally energy efficient, fancy electronics on your fancy air conditioner now, you need to install something that costs more than the air conditioner. And that is a fancy power quality monitor that makes sure that the power never has a spike or a dip and that it's a consistent voltage all the time. And, you know, you insert that into a climate like Southern California, where we have a you know, very, very populated area, small area with a lot of people in it, with a high demand, and you start to run into all sorts of voltage issues and different things like that. So in my personal opinion, the reason why equipment doesn't last as long is because efficiency standards, okay? So let me give you an example. Back in the day, I was taught how to work on air conditioning systems, and I wasn't taught the right way. Okay. First off, we didn't have vacuum pumps, pre-EPA stuff. We didn't have recovery machines. Okay. You just vented into the atmosphere, and it wasn't right. It was absolutely not right, but that's just how I was taught. Okay. When you look at, air conditioning systems, I was taught to charge by pressures. We didn't care about temperatures. Okay. It was literally just look at the gauges. Right. And my head pressure on an R22 fixed orifice air conditioner, I was told my head pressure needed to be 275 PSI head pressure. And then you would have a 65 suction pressure, R22. Okay. And for instance, if it was cold outside and your head pressure wasn't at 275, well, you just take the panel off the condenser and set it on top of the condenser fan motor, drive up the head pressure, and then your suction pressure should be 65 PSI, and you just add gas until it's perfectly there and call it a day. Now, that was wrong. There's nothing about that that works. Okay. There's so many different variables that cause those systems to operate. But the funny thing is that when we did charge systems that way, they seem to work okay. So why is it that back then we could half-ass charge a system the completely incorrect way, but today the charge has to be perfect for that system to work? And it's efficiency standards, okay? Oversized condenser coils, oversized evaporator coils back then allowed for extra refrigerant to store in the system and for it to still function properly. Today, we don't oversize things. We perfectly size them, and they have to operate perfect because they have computer boards that say it's not operating perfect and it shuts it off if you don't charge it right. And that's efficiency standards. Coil thicknesses, coil wall thicknesses, and, you know, just having fudge room built into it. The SEER ratings on those equipment that I was taught to work on was like 6 to 8, okay? Not 30, 6 to 8, right? And so in my opinion, that's why everything happens the way it does and why equipment doesn't last as long. So let's see, 100% right. Most failures are due to energy efficiency, cheaper materials, and digital over engineering. Yep, that is 100% my opinion too. So let's see what else we got going on in the chat right now. You went to a class at RSD going over the new A2Ls and Intelligent startup info. You like the Intelligent. You have experience with Trenton and Arctic Fox for KE2 controllers. Yeah, I really like Intelligent. Intelligent is super easy, and it's pretty much, for the most part, pretty self-explanatory. Like the first intelligence system that I worked on, like I just started pushing buttons and I figured it out. You know, I mean, it's pretty user friendly. So yeah, there's a very good possibility that we'll have intelligent at some point on my walk-in project out here. It may not start with intelligent because I have some plans, but it just depends. So pressure and temp are linked. You don't get to choose. Nope. Exactly. That's the point I'm saying. But I wasn't taught that way. But the systems worked after we charged it to that, right? But it's because they were really low SEER ratings and the systems were very forgiving back then, right? You could overcharge it and it would still work right. Today, you can't overcharge something because it'll just blow the condenser coil apart, right? With a microchannel condenser. So, all right, let's see what else we got going on there. Okay, cool. All right, let's see what else. Rules of thumb. Are they good? Are they bad? What's my opinion on those? So a rule of thumb, I think, is a great thing for an experienced technician. A rule of thumb is not a good thing for a non-experienced technician. Just like, in my personal opinion, using AI. AI is a valuable resource for an experienced service technician, but not for an inexperienced service technician, because I could very easily make AI give me two different answers by giving it just different questions and prompting it and leading it in different directions. But for an experienced service technician, like for instance, I was doing some electrical work on my walk-in box outside, and I was like, hey, you know what? I needed to make sure that I was running a ground rod into the ground, and I needed to make sure that the wire size was correctly. So I have enough understanding of electrical code to ask AI, hey, cite the electrical codes that tell me what size ground wire I need to run from my sub panel to my ground rod. And is this particular connector that I'm using to attach the wire to the ground rod appropriate for being buried underground? You know, and AI can give me answers and I can read it and be like, oh, that's not right. No, that doesn't make any sense, right? For an unexperienced technician, that can be very dangerous, right? AI can be a valuable resource, and so can rules of thumb for experienced technicians. But for non-experienced, I don't agree with rules of thumb. You can give guidance and basic stuff, but if you tell a service, like for instance, let's use the condensing temp over ambient. Condensing temp over ambient, there's a rule of thumb that, you know, again, one of the ways that we would charge equipment is we would look at condensing temp over ambient. You'd say that your condensing temp, which is the pressure converted to a saturated temperature, should never be 30 degrees over, or should never be more than 30 degrees over ambient. That is a valid rule of thumb. That really is. But do you charge to 30 degrees over ambient? No. And it also depends. Does it mean that sometimes a properly charged system will have a perfect 30-degree condensing temp over ambient? Yeah, it might, but there's other variables that affect it, right? So you can't just take a rule of thumb and walk with it just with blinders on. You have to be able to understand, okay, a rule of thumb gives me guidance. So I use condensing temp over ambient to this day all the time. And I tell it to my apprentices, okay, so we're working on a refrigeration system and I will use condensing temp over ambient, but just as a guidance, I will tell my apprentices, okay, my condensing temp over ambient is 28 degrees when I have this system fully charged. That's good. And then I'll say, what you're looking for, I use that rule of thumb to say, if my condensing temp over ambient is more than 30 degrees, we need to stop and figure out why, because it's very, very rare that you will ever see a condensing temp over ambient that is more than 30 degrees on a properly operating system. Another thing to understand is that if you have a microchannel condenser, your condensing temp over ambient might be 10 to 15 degrees. So you can't charge using those rules of thumb, but you can use those rules of thumb as a guide, as one variable, one metric when we're looking at the big picture, at everything. I'm going to look at the saturation temperatures, the airflow. We're talking about an air conditioner, condensing temp over ambient, evaporator TD, right? I'm going to look at all of that and then come up with a diagnostic, you know, or diagnosis essentially. So, all right, let's see what else we got going on in the chat here. When you're explaining to the electrician and the inspector what Article 440 is in the electrical code because they didn't read it, it says that you can put a 10 gauge wire on a 50 amp breaker. So Al Anonymous, that's a great thing. And I know Brian harps on that one too, because a lot of electricians don't understand. And this is where they start to get confused. That electrical code allows you to use 10 gauge wire on a 50 amp breaker because the compressor has a thermal overload in the compressor that is going to protect it. So you are allowed to use the 10 gauge wire because of the thermal overload. Okay. And a lot of electricians that don't understand air conditioning systems don't understand that. Mike Holt, who's electrical guru, right? He has all sorts of information. He has a great series of videos where he talks about that code. And I've heard him reference it a bunch of times because, yeah, you know, a basic electrician may not, and there's nothing wrong with this. It's because they're not refrigeration technicians. They don't understand that we're dealing with a motor that has thermal protection inside of it. And so that does allow us to use 10 gauge wire on that system because of that thermal protection built into that motor. If it didn't have the thermal protection, then yeah, we would have to be defaulting to sizing the wire, you know, for the proper current and all that stuff, you know, for the, anyways, you know what I'm saying. So, JJ is saying, no, it doesn't. Section 440B in the NEC explains why you don't 10 gauge. Yeah, so I don't know the numbers, but the concept is that on certain systems, you can use 10 gauge wire because the compressor has the thermal overload. So you should never use 10 gauge wire on a 30 amp breaker. It will burn the wire if it shorts before any other safeties. But you have to understand too, and it's not just the thermal overload, it's the actual, again, this is where we're going to get really technical and I'm starting to step out of my element, but it also has to do with the RLA of the system, right? Is it the RLA or the FLA, the full load amps or whatever too, because it's going to be a lot less. Anyways, yeah, this is where we step out of my area. All right, cool. Oh, you know what? I appreciate everybody that purchases merchandise from me at hvacrvideos.com. Thank you very much. The support really is awesome. I do have to highlight someone just simply because they placed a merch order that blew my mind. And I can clearly tell they probably, I think that he's done this before. His name's Justin. Justin, thank you very much for that order. You ordered 10 hats, 10 beanies. I'm assuming you ordered them for your employees. That was very, very nice. And again, everybody that helps the channel by ordering merch, thank you so very much. It really does help support this business, but that is really awesome. All right, let's see. I got a question for everybody in the chat right now, right? What is your favorite non-HVAC content that you watch on YouTube? What is the fit? Like, what besides HVAC? Now, it's really difficult because I watch a lot of HVAC stuff. But like for me, I like to watch in the morning. I wake up every morning at 4:45, right? And I by the time I get out of the shower and go sit down on the couch with my coffee, it's 5:10. And then I sit on the couch, turn on YouTube for a little while and watch some stuff. And I usually watch some sort of off-road recovery. Matt's off-road recovery, Fab Rats, you know, all those different, Robbie Layton. I watch all those different groups of people. Cletus McFarland, I watch some of that stuff like that. But what do you guys in the chat? What do you guys watch? You know, what's your favorite non-HVAC stuff that you guys watch? Let's see. Okay, cool. Theo Vaughn. Yeah, Theo Vaughn can be funny too. Oh yeah, there's a lot. Needs Gaming, Stud Pack, True Crime. Yeah, right on. That's all cool stuff. The walk-in cooler I'm building, is that for training or do I have a bunch of food? The walk-in cooler that I'm building is simply for training and for YouTube videos. That's what it's for. There's not going to be any food stored in that thing. It's going to be empty majority of the time. So you watch farming, comedy, basketball, gun channels. Yeah, man, I was really bummed when Matt retired from Demolition Ranch. I brain fart there for a minute. Yeah, I was really bummed. I watched Demolition Ranch, and then I loved watching his family stuff too. So Pew Pews, yep, 100%. Yeah, I love watching all that stuff. New spoiling valve. You saw the adjustment screw was a 1/4-inch hex head. Have I seen these? Are they going to continue to do this? Yeah, they did change everything. They've got a new adjustment stem. Speaking of that, for those that are chiming in right now, if you are going to the AHR Expo, I will be at the AHR Expo this upcoming next week, Monday, Tuesday, Wednesday. But Monday, Tuesday, you can find me at the Parker Sporlin booth for a good majority of the day on Monday and Tuesday. I will be spending some time at the Heatcraft Refrigeration booth on Monday. And then on Tuesday, I'll be spending some time at the Refrigeration Technologies booth, but majority of the time at the Sporlin booth. They're not going to have a lot, but they do have the new expansion valve adjustment knobs that they're going to be having or giving out for, limited quantities essentially at the booth. So definitely come to the Parker Sporlin booth. Earlier, the better. They may or may not have some of the new little brass adjustment coins or whatever you want to call them for adjusting the new valves. So, all right, cool. Reading through here. Most are not using copper. Okay, cool. Right on. All right. Well, do I have, oh yes, I'm reading through here. Okay, cool. Well, it's time for me to wrap this up. I really do appreciate you guys. I'm going to go out and have some dinner with my wife and my daughter and hang out with the family for a little bit. So I appreciate you. I'm going to cue up the outro music. We're not going to be coming back in because it just never works right. And the dogs are doing something different right now. So I really do appreciate you. I'm going to cue up the outro music. I hope to catch you on the next one. Definitely follow my social media if you're going to be going to AHR. If you're going to be out there on Sunday morning, we're going to be going to the Red Rock Canyon to go for a hike. I'll be posting information about where we're going to go for the hike, what times we're going to be there. I'll also be at the HVAC Tactical Awards on Sunday, then Monday and Tuesday doing events. And then Wednesday, I'll be walking the show just with no real anything going on. Myself, HVACR wife, my wife will be there. And if you see me, stop me. Even if I look busy, even if I'm talking with a manufacturer, just walk up and politely interrupt me and let's take a picture and we'll have a conversation, okay? I really appreciate you. Hope to catch you all in the next one.